Hello and welcome once again to Physicsify. Today we are again talking about vectors, and this time around we have part 2 to be covered, right? What are the things that we are covering in part 2? Not only are we representing the vectors, but we are also taking a look into the direction part, right? Let's go ahead, try to find out new things. So what is the first thing that we have in this class? Representation of vectors, right? What does this mean? This means that if you want to make a vector, what would you do? The general thing to do is to draw this arrow, right? Now this arrow has two parts to it. The first part is called the head, as you can see, and the part, the other part, the other end, this is called as the tail. So the head and tail of a vector should be very much known by every student who wants to understand about vectors, and I hope that this is pretty much easy. Now the thing is that it also has a magnitude. So how would you define that magnitude? We say whatever is the length of the arrow. I hope everybody can measure what length this is, and whatever length this tells us about the magnitude of this vector, right? And if I talk about the arrowhead, what is the arrowhead? This is the arrowhead. This tells us that in which direction we are trying to say our vector is. If let us say I draw a vector like this would become the direction, this would be the arrowhead, and this would become the tail, right? Moving on to the next points. Let's say we need to draw 5 Newton towards west. What is this 5 Newton? This 5 Newton is obviously the force that we want to draw towards west. So one thing you can draw very easily is that you want to draw it towards the left, because that is where west direction happens to be. Now let us say that okay, to define or to make this vector exactly, we must know 1 Newton is how much length, right? We have defined this very easily that okay, we are saying 1 centimeter is 1 Newton. So the next thing that we do is we can say that 5 centimeter would be 5 Newton. How? Unitary method, Baba. This everybody knows na, that 1 centimeter 1 Newton, 2 centimeter 2 Newton, 5 centimeter 5 Newton. So now if we draw this arrow, I hope you can see that this is pointing towards the west direction. This is obviously east. Those of you who don't know, this is north, this is south. So it is towards west, and if I say that this is a 5 centimeter arrow, I can say that this is my 5 Newton force towards the west, right? So if you can see this force, this vector, how is it written? Whenever you want to write down a vector, you draw this particular arrow on top of that thing. Generally this force would be with F for force, and this arrow on the top of that alphabet, this tells us that this is not a normal scalar thing, this is a vector, right? So this is 5 Newton towards west. You have drawn it completely correct, but if somebody wants to ask that what is the magnitude, what is the direction, you can tell that individually as well, that if I want to write down the magnitude of this vector, which vector? If I want to write down this vector's magnitude, I put it between two dundies, two bars, right? If you see, this bar tells us that now we are having magnitude of the force. This we call as magnitude of force, 5 Newton, right? And if we want to tell what direction is it, we can say that towards west justifies the direction of this force F, or the vector F. Alright, let's move forward. Now the next thing that we have is we're talking directions. I hope everybody knows the basic directions, but still if you don't know, hopefully we can make it more clear for you. So if we have these two directions and these two directions, I hope everybody can say this is north, south, east and west, right? Now if you want more directions, you can call out these directions, right? What is this direction? I hope you can see this angle we want to say is 45 degree. Similarly, this is also 45. All angles is 45. This is also 45. This is also 45. And these directions are going to be called as a little different. Let us say we draw it like that. This is also 45, 45, 45, 45. Every angle is 45. We are just bisecting. We say we are bisecting two directions while we draw it like this. Now should we call these directions? If you see closely, this is north, this is east. So we should call this as northeast, right? The next thing you see, this we call as northeast. If we have this south, we have this east, this is going to be called as southeast. Similarly, you can say southwest. Similarly, you can say northwest. So northwest is a direction that is at a 45 degree with both north as well as west. What is southeast directions? 45 degree with south, 45 degree with east, right? This is the basic direction. But guess what? In your paper now, questions come like anything. So let me tell you how questions will come. Let us say there is a vector drawn like this. And once this vector is drawn, you are being said it is 30 degree dash of dash. How will you tell? Now one thing that I notice is that obviously this is 30 degree, because if total is 45, this should be 30, right? Now this is 30 degree dash of dash. I know it would be either north of east or it would be east of north. How do I say that? Now if my vector was, let us say, something like this, this would have been east. If I move in this direction, I am going towards north. If I move this towards this, I move towards north. So I will say this is actually 30 degree north of east, right? I will write this down as north of east, right? Some people will say that I don't like north of east. I would like to say east of north. You can do that as well, right? In fact, I will say this angle over here, if this was 30, this would be 60 degree. If this is 60 degree, if I say this was the north direction and I take it here, here, I'm taking it towards the east. This is north and I do it like this. I take it towards the east. And if I take it towards the east, I can say this is also 60 degree east of north. 60 degree east of north or 30 degree north of east. Both are the same things. Let's do more examples. I think you can say that if a vector is drawn like this and it is written it is 50 degree dash of dash, what will you say? You will say that this is 50 degree. If this is 50 degree, this is going to be north of west. We go north of west. So 50 degree north of west. Or you can also say, if it is said as 40 degree dash of dash, this would be west of north, right? Let's take up one more example here. If the vector is drawn something like this and you are set 20 degree. Now this is obviously 20 degree. 20 degree west of south, right? 20 degree west of south. Or you can also call this 70 degree and you can say this is 70 degree west. No, 70 degree south of west. 70 degree south of west, right? I hope this direction part is clear to you now. Let's move ahead and try to do a little bit of questions. Question number 1, right? It says you have to draw 5 Newton 37 degree east of south. So 5 Newton over here is the magnitude. This is the direction. How do we draw it? We draw north, south, east, west, right? Let us do that. North, south, east, west. I hope everybody knows this basic part. And the next thing, if you say 1 centimeter is 1 Newton, you'll say 5 centimeters is 5 Newton. And if you want to draw east of south, you have to be somewhere over here. So let's draw a vector. We've drawn the vector 5 centimeter. And now if I want to mark an angle, if it is east of south, this angle should be 37 degree east of south. Similarly, if I have a question 2, I am set to draw 2 meter per second 30 degree west of north. What can I do? I can again draw the directions, right? North, south, east, west. Simple, right? Next thing, I know it is west of north. This means I have to draw somewhat over here, right? West and north are coming. So let's draw it out. If I draw this out, first of all, I'll just Draw my scale, I'll say 1 centimeter is 1 meter per second, so 2 becomes 2 meter per second. And once I draw this out, I can mark the angle as well. If it is 30 degree west of north, I move west of north, and this is my 30 degree, and voila, I am done representing vectors. I hope you are understanding how to represent and how to draw the directions, at least on a paper, once you know where north, south, east, west are. Correct? So now, let's give you more tricky points continuing from the previous session or the previous video. Tricky point number 1 is that a vector is unchanged. It will not change if you rotate it by an angle of 2 pi. So if you rotate it 2 pi, what is 2 pi? 2 pi means 360 degree. Pi is 180 degree. Please remember, pi is 180 degree, and that is why 2 pi becomes 360 degree. So if I had a vector something like this and I rotate, initially let us say I put it like this, then 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 this, and again like this. So I have covered a full 360 degree and my vector remains unchanged. Second tricky point is that you say that a vector can shift parallel to itself. We call this funda as free vectors, right? Free vectors means that you can shift your vector wherever you like, right? Let us say you had this north, south, east, west, and your vector was drawn something like this. If it is something like this in a space, you can shift it anywhere like this without changing its direction, without changing its orientation. You can keep it like this, or like this. It won't matter. It is the same vector. Alright. Now, tricky point number 3. This is the final thing that we are doing in this session, in this video. And what exactly do we say is that the angle between two vectors. Now this is important, so pay a little more attention. The angle between two vectors, if ever is asked for you to find, it is always the smaller of the two angles. Smaller of which two angles? Between the vectors when they are joined tail to tail. So joining the vectors tail to tail is very important. That's why I told you tricky point 2, that a vector can move parallel to itself in a space anywhere. And if you want an example on this, I'll give you a very simple example, right? First of all, you should know that this angle between the vectors, if let us say I call this as theta, right? This will always be between 0 and 180 degree, both included, right? So what exactly do we have here? Let us say we have two vectors A and B. I hope you can see we have A over here, something like this. Its arrowhead is towards right, maybe towards the east direction. Similarly, this is B. This is having some random direction. I hope you can see we have joined here tail to tail. Now, if we are asked what is the angle between the vectors, you can see two angles. If I talked about a smaller of two angles, which two angles am I talking about? I am talking about, let us say one is 110 degree. So other one becomes 250 degree. So which one should be your answer? It should be 110 degree, not 250 degree, because a smaller of the two angles was to be taken. We have joined it tail to tail. So angle between the vectors. If somebody asks me what is the angle between A and B? Angle between A vector and B vector, I will say it is 110 degree and not 250 degree, right? Some people will do this. They will give you only 250 degree. They will not give you 110 degree. And you will have to find out that, okay, we have joined tail to tail. We want the smaller angle. Let's see both the angles. If only this is given, you have to calculate this on your own and get to the answer, right? We'll talk about those things maybe in the next session. That was all from me today. I hope you thoroughly enjoyed it. If you have any doubts, any problems, help is being provided, but only for those who comment in the chat box. If you loved this video, do not forget to like and share amongst your friends, amongst your cousins, whosoever you feel might need it. And if you don't want to miss anything new, you can subscribe as well. This was all from me today. See you in the next one.